A very good morning to anyone who may be watching this video. My name is Jazshan from Year 1 Medic, and my topic for today is engines. Yes, engines. So, what on earth would a medic student have to do with engines? Nothing. This is just my own fascination with engines. And today I'm here to make it your fascination as well. So, what I'm going to talk about today is, basically the definition, what are engines, and then the sources that power these engines, how they came to be, and the types of mechanical engines according to their categories. So, back to the question, what are engines? Engines are basically anything that converts any other energy into mechanical energy. And what are these any other energies, you may ask? And that includes a long list of potential energy, heat energy, chemical energy, electrical energy, and nuclear energy. So, do you see a pattern here? In case you haven't realized, both nuclear energy and chemical energy also release heat. That means that heat is the main intermediate energy for the engine. Now I'm going to talk about the history of engines. So, back when engines were first created, they were powered by humans, animals and all, but animals came later because we thought that they were complex enough that they required a human to do it. So, a good example is the Greek crane you see over there in the corner. The white, birchwood, birchwood crane that is made out of pulleys and just strings and ropes and engines. Then we realized we no longer need humans. We could use animals. So you see that picture with a large crankshaft and four. That is advanced animal powered engine that uses a center large gear and smaller gears. This is a good example of a gear reduction system where there's one large gear that is because it's bigger, right? And then there's a smaller gear. One rotation of the large gear rotates the small gear a lot of times, and that's what we call a gear reduction system. Now I'm going to talk about the types of engines according to various categories because there's just so much engines. If I tried to put it in this 8 minutes that I've got, I wouldn't be able to explain all. So I'll explain the most important. By fuel, which is the first criteria, would be two types. There's compression ignition and spark ignition. So compression ignition means you have this chamber, and then there's the input gas, that the injector, I would say, the gas injector that injects the gas. And because this piston is canister, right? After a certain point, because the fuel is very volatile, what happens is it ignites because the pressure of the fuel is too high and it ignites. This ignition triggers an explosion and the piston moves entire full rotation. If there's a spark plug, then we call it a spark ignition engine. And instead of waiting for the pressure to trigger it or cause it to move around, we just use the spark plug to do it at fixed intervals, which is much more safer in this aspect because there's less wear and tear on the piston itself. You're not using the piston at full pressure at all times. Now I'm going to talk about the types of engines by strokes, which technically means number of rotations per fuel burn. That's the 2-stroke engine, 4-stroke engine, and the 6-stroke engine. If you notice, between the 2 and 4 itself specifically, there's more steps to it. There's not just combustion and compression. There's the intake and exhaust, which means the pressure is controlled and there's less pressure acting inside the system at all times, meaning that only when it's needed we take in the pressure. This means that there's a less wear and tear. And then there is the 6-stroke engine, which has even more steps. There's a condenser, steam power stroke. So there is even less pressure acting upon the engine at all times. Now we're going to go to number of cylinders. So what are cylinders? It's basically that container with the piston itself. And the more of this you chain together, the stronger the output power. So what's the benefit of this? A multi-cylinder piston is much more powerful, and the force transmission is a bit more smoother. You see, between all these 4 pistons that you see in this picture, right, they don't trigger simultaneously. There's a few milliseconds, maybe nanoseconds worth of delay, And when that occurs, it means that the piston moves up and down ever so slightly at a different time, and the crankshaft, the snake-like ladder thing that you see, is basically moving at different parts of it are moving at different intervals, and this causes it to rotate up and down very rapidly at prolonged periods. So what's the problem with multi-piston engines? It's basically that these intervals that I've said are so important. If you make a mistake, what happens is basically it could misfire and your engine is going to break because of force. Now I'm going to talk about the arrangement of these engines. There's inline and there's horizontal and there's opposed. Inline is basically when all the engines are in one direction. That means that the force applied is just downwards lah, inline vertical, which is probably the only type of inline that I've heard so far. And then there's horizontal engine and the opposed cylinder engine, which both basically means the pistons are on opposite sides, and when they expand and contract at the different times, basically the force they produce is cancelled out as one pushes it and the other one pulls out. So there's less force on the crankshaft. But the problem is the net torque is less long. There's less force on it as well. That's a good thing and a bad thing in the aspect that the crankshaft doesn't get much pressure on it, but also there's less force moving the crankshaft. Now I'm going to talk about V-type and W-type. V-type and W-type engines basically have, multiple directions where the force is moving. So it means that force isn't pushing from one direction and it's not going to break the crankshaft as fast as the inline. So V-type splits it with two directions, W-type splits it into three directions where the force originates from. And then there's radial. Radial means that your force is, radial, which is good, yes. And there's much more torque. But the problem that lies in this is the fact that if you misfire a piston, it can really tear itself to shreds. And then I've saved the most, I would say, mundane for last. That's the double cylinder and the single cylinder that is produced at the end. So with that, I think I've explained the basic types of engines and their arrangement and all. And I think maybe, just maybe, I might have been able to instill some sort of passion for engines in you. And with that, I take my leave. Thank you.